Hello, this is worksheet 5.3. Let's simplify some radicals. All right, this is going to be awesome. Radical, man. So let me write some perfect squares on the top of the page because these are the values that we hope to be able to factor out of the values underneath the square root symbol. So think of what is the biggest perfect square that is a factor of 8. It's 4. The square root of 8 is the square root, same as the square root of 4 times the square root of 2. So that's where I take it, and then from there I know the square root of 4 is the whole number 2. And then the square root of 2 I can't break down anymore. There's no perfect square that factors into it. So that is my most simplified exact answer. Number 2, what's the biggest perfect square that goes into 50? 4 doesn't, 9 doesn't, 16 doesn't, 25 does, 36 does not, 49 does not, and it doesn't make any sense to go any bigger than that because we're only trying to go up to 50. So the square root of 50 is the same as the square root of 25 times the square root of 2. You can check that by putting this together in your calculator, and you'll see that you get the same messy decimal as that. But this is a little bit better, and now why we tried to factor out a perfect square is because the square root of 25 is just 5. So this is equivalent to 5 times the square root of 2. That is the most exact answer and most simplified answer. Boom. Here, like 4 goes into 80. 4 is a factor of 80. But keep trying to find a bigger one. Like 9 doesn't, I know that. 9 times 9 is 81, so we just miss. But see if 16 does. 16 does. You save yourself if you invest a little bit of time trying to find the biggest perfect square. 16 goes into it 5 times. You take 80 divided by 16, you get 5, so you know that 16 times 5 is 80. The square root of 16 is 4. So the best answer is 4 times the square root of 5. Here, 9 is the biggest perfect square that goes into 45, so 3 roots of 5 is the best answer. Square root of 70, that's funny, we debated that one, and I can't think of a perfect square that is a factor of 70, right? You guys get stuck on that one? Like, I don't think, oh, okay. I don't think we can break it down anymore. Like, I think that's the most simplified. So, yeah. There, that's a simplified. 9 goes into 63 7 times, so it's the equivalent to the square root of 9 times the square root of 7. And again, we used a perfect square. I like to put that out front because we want our whole number out in front. The square root of 9 is 3. So the best answer is 3 times the square root of 7. Now, we can never have a perfect square left as a factor of our answer. So that's why we've been doing what we were just doing right there. Another rule of simplifying radicals is you can't have a radical on the bottom of a fraction bar. So to undo that, multiply by whatever that radical on the bottom is. On the top, the square root of 5 times the square root of 2 is the square root of 10. On the bottom, the square root of 2 times the square root of 2 is equivalent to the square root of 4. And the square root of 4 is equivalent to 2, like the whole number 2. So now we don't have a square root on the bottom anymore. Now when you end up multiplying the top, sometimes you get a different square root value. So you got to ask yourself, can I break down the square root of 10 anymore? And you can't. So you're done right there. You'll see what I mean though. I think that'll probably come up in a little bit. So here, number 15, I don't think we can break any of these down, but it's good to try. Ooh, we could actually break down this one. So the square root of 12 is equivalent to the square root of 4 times the square root of 3. Yeah. And then the square root of 4 is 2. So this is equivalent to 2 roots of 3. You know what, folks? I can't do that. I'm going to jot down my perfect squares. It'd really be nice. I bet I can cut and drag this every time. It's just nice to see these. It's easier to see what might be a factor of the number. So on top, we really have 2 square roots of 3 over the square root of 15. And then we don't want to have a square root on the bottom, so we multiply by the square root of 15. So on the bottom, the square root of 15 times the square root of 15 is the square root of 225. The square root of 225 is the whole number 15. And so if you start realizing that trick that you're multiplying or you're really squaring the square root of some number, Squaring and square rooting cancel out, so you just get that number. Here we'd have 2 times the square root of 45. Oops, 2 times the square root of 45. Why I wrote that number was because I was already starting to think ahead about what perfect squares go into 45. So we're not quite done yet. We need to try to simplify this, the square root of 45. The square root of 45, well, I guess I'm going to do some side work over here. The square root of 45 is equivalent to the square root of 9 times the square root of 5, which is equivalent to 3 roots of 5. Because the square root of 9 is 3. So really on top, we have 2 times 3 times the square root of 5 over 15. But then, if you think about like second grade, we learned that 2 times 3 is 6. So it's the same as 6 times the square root of 5 over 15. Holy cow! And then from here, folks, we can simplify this fraction. And it's just the whole numbers that we try to simplify. That says 6 divided by 15. Do not go into the radicals. So try to simplify that fraction. You can divide the whole number 6 by 2 and the whole number 5. Well, that's not false, but that's actually divided by 3 because we're looking for a number that we can divide the top and the bottom by. Let me get rid of this. We can divide the top and the bottom both by 3 to simplify that fraction. So on the top, we have 2 roots of 5 over 5. And the magic part is, folks, if you put this in your calculator, so this is the most simplified answer. We followed all of our rules. You should get the exact same equivalent thing as right there, except for this is appropriate and simplified and exact, and the one up there is not simplified. We did it. Number 9, can't have a radical on the bottom, so multiply by it. So we get 2 on the bottom. And on the top, we get 5 times. You can multiply square roots together, so you get 5 times the square root is 6. On the bottom, you could multiply the top and the bottom by the square root of 20. Totally doable. I'll jot that down. You could do that, and then you'd get 2 times the square root of 80 over 20. And then that's equivalent to, well, actually, is there a perfect square that goes into 80? 16 does. I think we already did that on a different problem. Square root of 80 is the same as square root of 16 times the square root of 5. Square root of 16 is 4. So we get 4 roots of 5. So on top, we actually have 2 times 4 times the square root of 5. On the bottom, we've got 20. So then these are whole numbers that I can multiply on the top together. So 2 times 4 is 8. Oops, times the square root of 5. There we go. And then on the bottom we have 20. So you can multiply whole numbers together. You can also simplify fractions with whole numbers. So you can divide 8 and 20 by 4 to simplify the whole number fraction. So you get 2 over 5 square roots of 5. There we are. I was going to show you there's another way to do that one. Do you want to see that? Let's do it. I think we have enough time. So, what I would have done instead, let me rewrite this problem, is the square root of 4 is 2 on top. So really you have 2 times 2. And on the bottom, we already talked about how, maybe we didn't, the square root of 20 is the same as the square root of 4 times the square root of 5, which is really just 2 roots of 5. So really you have 2 roots of 5 on the bottom. So then these 2's really cancel out, and then we need to multiply the bottom by the square root of 5 times the square root of 5 to undo the square root. So on the bottom we have the whole number 5. On the top we have 2 times the square root of 5. That was faster. So if you simplify the radicals before you start trying to undo the radical from the denominator, it might save you some time. But you know what? However you get the right answer is cool.